Hello everyone. Today I'm going to talk about deductibles. The deductible is the amount of each claim that the policyholder is responsible for paying before the insurer will pay a claim. In this section, we will focus on two types of deductibles: ordinary deductibles and franchise deductibles. As a reminder, if a question only says deductible, it generally means ordinary deductible. So what's the difference between ordinary deductible and the franchise deductible? Let's use an example. So with the ordinary deductible of 500, a policy pays nothing if a loss is 500 or less, and pays 200 for a loss of 700. So the deductible 500 will be deducted from 700. That's what insurer will pay 200. With a franchise deductible of 500, a policy pays nothing if a loss is 500 or less, which is the same as ordinary deductible, but it will pay 70 for a loss of 700. So here the 500 is just a standard. Once you above 500, then you pay the whole amount 700 instead of 200 like in the ordinary deductible. So for ordinary deductible, the notation is as follows. Let X be the loss variable. For a policy with an ordinary deductible D, the policyholder, so here emphasize the policyholder, not insurer, pays the loss up to D because their loss is capped at D. If it's more than 500 in previous example, they only pay 500. The rest will be paid by the insurer. So their loss is capped at D. X capital D is equal X if X is less than D, and if X is greater than or equal D, then the X capital D will just be D. Therefore, the insurer will be responsible for covering the remaining amount, which is X minus D plus, which is equal to 0 if X is less than D, less than or equal D. If X is greater than D, then it will be X minus D, because insurer only pays the amount that is greater than deductible D. Naturally, the contribution of the policyholder and insurer must add up to the full loss amount. Therefore, X capital D plus X minus D plus is equal X. The expected value of these two items, X capital D and X minus D, will add up to expected value of X. And if we remove the items from left to right for the formula, then we got the expected value of X minus D plus is equal expected value of X minus expected value of X cap at D. Now we know the definition of ordinary deductible. Of course, we are going to calculate the expected value of this ordinary deductible, the payment after ordinary deductible. So expected value will be the integral of X minus D times the fx, which is a density function, probability density function, integral from D to infinity. Similarly, the case moment of the payment variable will be as follows. Further, we can use the survival function to calculate this expected value of X minus D plus, which is just the integral from D to infinity Sx. That's the survival function. These two formulas actually are relatively easy, similar to what we learned before. Remember when we, from note 4, we already know the formula or deduce the formula for expected value for X cap and U, which will be the integral from 0 to U Sx dx here. And now we think about it, the normal unlimited moment Ex is integral of survival function Sx, but the integral is from 0 to infinity. So naturally, we can see that expected value of x minus d plus is the same survival function, but from d to infinity. This is just one way to prove this formula, but there are other ways to prove it. I will leave this to you. On the notes, there's different ways to prove these formulas. Okay, let's look at example A. Loss amounts have a distribution whose density function is this. Insurance coverage for these losses has an ordinary deductible 20. Calculate expected insurance payment per loss. So the easiest way would be using the formula from previous slide, x minus d plus, which would be equal d to infinity as x survival function dx. Now, well, in this problem, it gives fx, so we can calculate fx. The bigger fx will be small fx dx, which if you use integral will become 1 minus 100 x 100. Now you can get sx. It's basically just this part is fsx. Once we have sx, we can calculate e x 20 plus will be the integral of 20 to 100 is sx, which is 100 minus x divided by 100. So dx. This is a simple integral problem, so I will leave it to you, but the final answer is 6.5. Let's look at example B. Loss amount has a discrete distribution with the following probability. An insurance coverage for these losses has a deductible 500. Calculate expected insurance payment per loss. This is a discrete distribution, but it's actually simpler than a continuous one because all you need to do is add them up. So for this case, first we look at each loss amount. First loss amount is $100. According to definition, the deductible is 500, then the payment should be 0 because 100 is less than 500. For the second one, loss amount is 500, so it's still the payment from insurance company will be 0. The third one, payment is 1,000, then the payment from loss is 1,000, the payment from insurance company will be 500. And last one, loss is 2,000, payment will be 1,500. Once we have this, all we need to do is calculate expected value, which is the value x times xi times probability pi, pxi. I is equal 1 to 4 in this case. So the first two is 0. So really we just need to calculate the third one and the fourth one plus, which is equal to 250. Now let's look at this example. Losses follow a two-parameter Pareto distribution with alpha equal 2 and theta equal 2000. Calculate the expected payment per loss on a coverage with ordinary deductible 500. So what we need to calculate is E x minus 500. From previous, we already know that this is equal ex minus ex capped at 500. Why do we want to do it this way? Mostly just because this formula is given in the exam spreadsheet or sheet. That's why normally it's easier for you to use this formula to calculate that, and we know this is given, so it will be here. 1 minus theta x plus theta alpha minus 1. Basically, it will become theta alpha minus 1 times, because this pi is cancelled out, you only get theta x plus theta alpha minus 1. You just need to put in the numbers now. 2000 2 minus 1 times 2000. 500, x is 500 plus theta 2000. Alpha minus 1 is 1. So this will get to 1600. So in this problem, you could use your regular way to calculate expected value, but in order to use the formula from this sheet, you can do it this way. Now let's talk about payment per loss versus payment per payment. In general, we use YL to represent the payment per loss variable and YP for a payment per payment variable. As a refresher, for a policy with the ordinary deductible, expected payment per loss is just the expected value of YL is just equal expected value of E x minus d plus. As shown in the previous example, the expected payment per payment is the expected payment given there is actually a payment, which occurs when the loss is greater than the deductible. Therefore, expected loss per payment is equal expected loss payment per loss with the condition that YL is greater than 0. So it's the expected value of x minus d conditioning on x is greater than d. The rest is just similar. It's also called excess loss variables. YP is the random variable for the payment per payment on insurance with the ordinary deductible D, and it's also called excess loss variable. It's the payment per loss random variable condition on X is greater than D. Here is just a formula for payment per payment. How do you calculate its probability? So probability of YP is less than X is the probability of X minus D, which is YP, less than X, conditioning on X greater than D, which can be further reduced to Fx x plus D minus Fxd over 1 minus Fxd. Survivorship of payment per payment will just be probability of YP greater than X. So based on the previous formula, you can further deduce it to be Sx x plus D over Xxd. So I will leave the proof to you guys. So here is the payment per payment expected value calculation. Use the first three principle. You can just write out the expected value of yp is equal expected value of x minus d over conditioning on x over d. Then the rest of deduce is similar to what we had before, except this one is conditioning on x greater than d, so there is a survival function sd in the denominator. So eventually it will get to here. It is expected value of this is just payment per payment is just the expected value of payment per loss over this SD, the survival function, which is just the probability of x minus x is greater than d. And there are some other formulas which is similar to what we talked about before. It's just a slightly transform of what we have done. So I'm not going to elaborate on that. Here is just a more formal definition for mean excess loss. So we know x capital D is called a limited loss variable because loss is limited by D, while x minus D conditioning on x greater than D is called excess loss variable. It means denoted by ED is the mean excess loss function, also called mean residual life function. ED is basically just the expected value for x minus D conditioning on x greater than d. So this is just a definition and the formula we talked about in previous slides too. Now let's look at this example 1. Losses follow a single parameter Pareto distribution with alpha equal 2 and theta equal 400. Yp is the payment per payment random variable for coverage with a deductible of 1000. Calculate the probability that the payment per payment is not greater than 600. So we write out the question P payment per payment YP is less than or equal to 600, which basically is the same as P x minus 1000 less than 600, conditioning on x is greater than 1000 because it is payment per payment. Now it can be further deduced as x less than 600 given that x is greater than 1000. This would further be probability of x 1000 x divided by p x greater than 1000. Then this is just a function 1600 minus 1000 divided by s, because s greater than 1000 is just s survival function s 1000. Then that you can use the formula to calculate that to be final number is 0694. Okay, now let's look at this example 2. Loss amounts have a distribution whose density function is as follows. An insurance coverage for these losses has an ordinary deductible 20. Calculate the expected insurance payment per payment. So if you recall, we actually did a very similar questions earlier, except that earlier the question is asking about payment per payment. Now let's just use the formula to do this one. So the formula what we have is expected value of Px greater than D. And earlier we already know about this part, expected value payment per loss. To do that, this part was you can use the function or formula sx dx, and this part is just sd. So what we need to know first is to calculate sd. Now since fx is given, we know fx is just integral of f small fx, which we already calculated earlier in earlier problem, and we know it's this. So sx is just 100 minus x 100. With this sx, then we can calculate this integral, and eventually we can get this is integral is this 0.0496 is the SD, so we can get it's about 16. Remember, this is what we got earlier for payment per loss. So basically, payment per payment is just payment per loss over the SD, which is the survival function for D. D is the deductible. Now let's look at example 3. Loss amounts have a discrete distribution with the following probability. An insurance coverage for those losses has a deductible 500. Calculate expected insurance payment per payment. So if you recall, we had a similar question earlier before too, except that previously we are talking about a payment per loss. Now we can still use the same concept to calculate payment per payment. Similarly, we first calculate how much you will pay for each of the loss. Since the deductible 500, so these first two rows we will pay 0 because it's less than or equal to 500. For the third one, you will pay 500. For the fourth one, you will pay 1500. Now, the expected value for this payment will be exceeded divided by probability of x is greater than 500. So this part we already calculate to be 250, and this part probability of x is greater than 500 is the last two, which is the 0.2 plus 0.1. So you will get this value. If you are not sure how we get this number, you can go back to previous example to find out. Now let's look at this example. Losses follow a distribution that is a mixture of two exponentials with weights 0.75 and 0.25, and the parameter theta 1 is 1000, theta 2 is 2000. An insurance coverage has an ordinary deductible 500. Calculate the expected payment per payment on this coverage. So again, we will use the definition for payment per payment. We know that E500 is expected value of x greater than 500 and probability of f greater than 500. Now this question is slightly different in that this question is a mixture of two exponential. So, but again, we can use what we learned from mixture to calculate the fx and the sx first. So we know for a mixture fx, this is the, so you just need to wait for both to get fx. This, okay, here 7.5 and 0.25 is the weight. This fx for this distribution, exponential distribution, which we know from what we learn about exponential, or it's also in the formula. But exponential distribution is just itself, which is easier. Now After you calculate fx and fx, then you can calculate sx. Xx just 1 minus fx. With this sx, you will be able to calculate probability of x plus 500, which will eventually you get this 6496. Then we can calculate the expected value for x greater than 500. This part, basically, this part, there are two ways to calculate that. One is you can use this expect value minus 500. Again, this is because this is given in a formula. Alternatively, you can just use the formula Ex would equal this 500 Sx dx. I'm running out of space, so I'm not going to write out everything, but it's in the notes if you are not familiar how you get to the final answer. Basically, we are just utilize the knowledge from mixture together with the knowledge about expected value for payment per payment cases. Then you will arrive at the final answer. Here are some special cases for the mean excess loss. For exponential uniform Pareto and single parameter Pareto, you can find the formula here. It's not difficult to deduce this, so I will leave this to you, but if you have questions in the notes, there is a demonstration of how you deduce the formula. Now let's look at some examples regarding the special cases. The first example is about uniform distribution. So loss follow a uniform distribution 0 to 1000. Calculate the expected payment per payment on this coverage with ordinary deductible 100. Now this is a uniform distribution, then we can write it as follows. So, the payment per payment follows this. So basically it's this. And we know the expected value for this will be this. You can calculate from previous example, previous formula, or you can just using your knowledge of uniform distribution. We know the expected value is just basically the mean of this distribution, which is the midpoint. That's why it's 900 divided by 2. Okay, this example is about two-parameter Pareto distribution. So loss follow a two-parameter Pareto distribution with alpha equals 3 and theta equals 100. If an ordinary deductible is 220, calculate the average payment per payment, the variance of a positive payment amount, the probability that a non-zero payment is greater than 10. Okay. First, we calculate the expected value payment per payment EYP, which is E20. So this is just 100. You can use the formula to get to here. And then the second one is kind of variance. The variance of YP. It can be calculated by doing this. Yp squared minus E yp. This is the formula for variance. You should know by this. And then you can again using the formula to calculate that. 10800, where this part is to, this is just formula. You can find it in a spreadsheet or in a book. And probability of y greater than 10 is 120. Yeah, this is formula 2. So these questions are not difficult. You just need to know to apply the numbers to the formula to get the result. Now let's talk about effect of inflation on average payment per loss. We talked about inflation before. Basically, it's just suppose the inflation rate is R, then the new loss will be 1 plus R times X. So if we set this Y new loss, we call YL equal 1 plus R X over D. D is minus D. D is the deduction. Then we can deduce it to be YL is equal to 1 plus R times X minus D over 1 plus R. Basically, you just pull the 1 plus R outside of the parentheses. This is a practice we have done earlier before. Basically, you just apply this factor and then we try to deduce the formula to get back to original X. So once we have this, we can utilize the formula for X for the loss of average payment per loss. So here is the expected value of payment per loss. Expected value of payment per loss is just 1 plus I times EYL, which is equal to 1 plus I times EX minus D over 1 plus R. Then for this, we know it's this, just separate between the two. So this is not difficult. It's just a basic algebra. Similarly, for average payment per payment, the deduction of this is not difficult. The only difference between this and the previous one is there's another additional conditions that x has to be greater than d over 1 plus r. So basically this you translate into the denominator survival function as x, where x is equal to d over 1 plus r. So it's just another factor in this situation compared to average payment per loss.